If algebra has been a weak spot in your Praxis 5165 prep, this is something you need to fix before test day, because it's not just a small part of the test, it's a major chunk of your score. Welcome to the Praxis channel. I'm Emily. I'm a licensed educator and test expert, and this channel exists to help you understand exactly what's on your certification test and walk in ready. Today we're covering 6 algebra concepts that appear on almost every version of the Praxis 5165 with a multiple choice example for each one so you can see exactly how these questions are framed on testing. Let's get into it. The Praxis 5165 is the mathematics certification exam for aspiring secondary teachers. It has 66 selected response questions and runs 180 minutes. You'll have access to an on-screen graphing calculator throughout. The test is split into 4 domains: number and quantity in algebra at 30%, functions and calculus at 30%, geometry at 20%, and statistics and probability at 20%. Within the algebra subcategory specifically, there are 9 major skill areas, covering everything from rewriting algebraic expressions and creating equations to solving systems, working with polynomial zeros, and simplifying rational expressions. Today's 6 concepts draw from the highest frequency topics across those 9 areas. Here's why mastering these 6 concepts specifically matters for your score. Algebra on the 5165 is not just procedural. About 25% of all questions are framed as tasks of teaching mathematics, meaning you're asked to evaluate a student's work, identify a misconception, or choose an instructional strategy alongside the content itself. That means that every algebra topic you study needs to be understood deeply enough to explain, not just to perform. Strong algebra performance also supports your work across other content domains. Functions, calculus, and even statistics problems on this test routinely require algebraic manipulation. Algebra isn't a silo, it's the foundation that runs nearly every other section. Okay, let's take a look at concept number 1, writing algebraic expressions in equivalent forms. This is all about the ability to use the structure of a polynomial or exponential expression to rewrite it. Factoring, changing bases, recognizing differences of squares, and rearranging formulas to isolate a variable. This comes up across multiple question types, and here's an example. The answer is B. This is a classic difference of squares. A squared minus B squared factors as A plus B times A minus B. Here A is X and B is 4. Option A would expand X squared minus 8X plus 16, which is not the same. Options C and D don't produce the correct middle terms. Concept 2, creating and solving equations and inequalities. The test emphasizes the ability to create equations and inequalities in 1 or 2 variables, solve them, and graph solutions, including in modeling contexts. You need to move fluidly between a word problem and the algebraic equation it represents. Here's some practice. A student earns $12 per hour at a part-time job. She wants to earn more than $150 in a single week. Which inequality represents the minimum number of hours, H, she must work? The answer is C. The problem says she wants to earn more than $150, not at least $150. So the strict inequality greater than applies, not greater than or equal to. Option A is an equation, not an inequality. Option B points in the wrong direction. Concept 3, solving quadratic equations, multiple methods. The study companion explicitly lists factoring, completing the square, and the quadratic formula as methods you must know, along with discriminant analysis to determine the nature of solutions. Expect to use all three and to identify which method is most efficient. Here's an example. What is the discriminant of the equation 2x squared minus 4x plus 5 equals 0? And what does it indicate about the solutions? The answer is B. The discriminant is b squared minus 4ac, which is negative 4 squared minus 4 times 2 times 5, giving 16 minus 40, or negative 24. A negative discriminant means the equation has two complex non-real solutions. Option A incorrectly computes the discriminant. Option C confuses a negative discriminant with a zero discriminant. Concept 4. Systems of equations, linear and quadratic. The study companion covers solving systems of two linear equations as well as systems of one linear and one quadratic equation, both algebraically and graphically. The intersection points of graphs and the solution set of a system are directly connected. Let's try another sample problem. Which of the following is the solution to the system? Y equals x plus 2 and y equals x squared minus 2. The answer is B. Set x plus 2 equal to x squared minus 2. X squared minus x minus 4 equals 0. Wait, substituting x plus 2 into x squared minus 2 gives x plus 2 equals x squared minus 2. So x squared minus x minus 4 equals 0. Actually solving by setting equal. X squared minus 2 equals x plus 2. So x squared minus x minus 4 equals 0. Testing x equals 2. 4 minus 2 minus 4 is not 0. Let me use the values. X equals minus 2, y equals 0, x equals 2, y equals 4. Both satisfy both equations. Option A misses the second solution, while option C and D have incorrect intersection points. Concept 5, polynomial zeros and factorization. The study companion covers using factorization to identify zeros of polynomials, applying the remainder theorem, and using zeros to sketch a graph. This is a consistently tested area because it connects algebraic manipulation with graphical interpretation. Here's an example. A polynomial p of x is divided by x minus 3, and the remainder is 7. What is the value of p of 3? The answer is C. By the remainder theorem, when a polynomial p of x is divided by x minus a, the remainder equals p of a. So dividing by x minus 3 gives a remainder of p of 3. The remainder is 7, so p of 3 equals 7. Option A would only be correct if x minus 3 were a factor, meaning a remainder of 0. Concept 6. Slope, intercepts, and linear equations in various forms. This calls out the ability to extract and interpret information from a linear equation in slope-intercept, point-slope, and standard form, calculating slopes, finding intercepts, and interpreting them in modeling contexts. This is foundational and connects to the functions domain as well. For example, a line passes through the points 1, 5, and 4, 11. What is the equation of the line in slope-intercept form? The answer is A. Slope equals 11 minus 5 divided by 4 minus 1 equals 6 divided by 3 equals 2. Using point slope with 0.15, y minus 5 equals 2x minus 1, which gives y equals 2x plus 3. Option C gives the wrong y-intercept. Plugging in x equals 1 gives 7, not 5. Now that you know the 6 concepts to focus on, here's how to prepare. Start by downloading the free study companion for the 5165 from praxis.ets.org. The algebra section runs from pages 7 through 9 and covers all 9 skill areas with discussion questions. Work through every discussion question. They're designed to test whether you truly understand the material, not just whether you can recall a formula. Then take the interactive practice test that comes with your registration. Use it as a diagnostic tool, not a confidence check. Your results by content category tell you exactly where your prep time needs to go, and algebra is almost always one of the areas candidates leave the most points on the table. Remember that about 25% of questions involve teaching applications. For each concept in today's video, ask yourself, how would you explain this to a student who got it wrong? That's the frame the test uses, and practicing it will sharpen both your content knowledge and your test performance. Study.com's Praxis Mathematics prep courses are built around the specific domains of the 5165 with practice questions that include both pure content and teaching application scenarios, detailed answer explanations, and a personalized study plan built around your results. Algebra is 20% of the Praxis 5165, and if you've built a strong command of these 6 areas, you've laid a real foundation for the entire test. Rewriting expressions and creating and solving equations, quadratic methods, systems, polynomial zeros, and linear forms, those are your targets. If this video helped you, give it a like, subscribe, and drop a comment below telling us which of these 6 algebra concepts is giving you the most trouble. We read everything, and it helps shape what we make next. Good luck.